Hello everyone, we meet again. Over the next 30 minutes, I will take you to witness a cosmic antimatter engine at a frequency of 1 trillion operations per second. The remnants of a dead star, transforming into a bursting shower of positrons. Experience how science has evolved over 30 years, taming the antimatter storm unleashed by the supernova explosion, directly pointing at the Fermi telescope, unveiling the gamma-ray glow spanning 20 degrees of the celestial sphere. Announcing pulsars is the true source of positron cosmic rays. May this journey of exploration lull you into a peaceful slumber. Slept soundly until dawn. In the depths of space, 800 light-years from Earth, concealing antimatter factories that cannot be directly observed. It continuously generates high-energy positrons. These antimatter particles at the microscopic scale, journeying through the vast cosmos, and collide with Earth. Throughout most of human civilization's evolutionary history, we know nothing about the existence of this strange source. The vast majority of positrons bombarding Earth, because it was detected, ultimately absorbed entirely by Earth's atmosphere, until humans began observing from a perspective beyond the Earth's boundaries. This phenomenon has only gradually begun to show signs. In 2011, NASA was not part of the International Space Station. The cutting-edge particle detector Alpha, operating at an altitude of approximately 200 miles. Magnetic spectrometer successfully started up and is now operational. What discoveries did the detector reveal? The answer is as you expected. The existence of these subatomic particles, positrons. This is within scientific expectations. However, its scale far exceeded expectations. The sheer magnitude of the detected positrons, making conventional sources, it is no longer possible to provide a sufficient theoretical explanation. So where exactly do these excess positrons originate? Until recently, only then can we trace back the true cause of this cosmic antimatter shower. The key clues point to another high-profile case. Major discoveries in physics, a peculiar gamma-ray haze known as Gemengard, the mysterious radiation source, first observed by humans in the 1970s. This unknown gamma-ray emitter, what is the true nature of it? It is subjected to an unusually dense high-energy, positron bombardment phenomenon. What kind of intrinsic connection exists between them? In the night sky above us, within the constellation region of Gemini in the northern celestial hemisphere, an extraordinary astronomical phenomenon is currently unfolding. NASA's Small Astronomy Satellite 2, launched in 1972. An unknown gamma-ray source has been detected. However, constrained by the technological capabilities of the time, researchers can only determine the direction of this radiation source. Trace back to this more expansive region within the Milky Way galaxy. Further research cannot be conducted. That is precisely why. The ultimate source of the radiation, hidden in interstellar space for decades. However, this mysterious radiation source has been given a specific name, German. The name was coined by Italian physicist Giovanni Beniamini, proposed in 1976. His entire life, all are dedicated to the study of this mysterious celestial body. This is a clever pun, combining the name of the constellation Gemini. It has also incorporated the Italian dual suffix form, the elements of Gemina. It is also associated with gamma, clearly indicates the type of radiation emitted by the celestial body. Additionally, in the Milanese dialect of Beniamini, Gemengel, it is also a pun with a special meaning he wasn't there. This name, the situation at the time when the source of the radiation was unknown, highly compatible. Until 1983, Beniamini and his research team finally achieved a major breakthrough. They utilized the Einstein X-ray satellite. Gemini has been successfully identified, emitted faint X-ray signal. This achievement signifies, although the exact location of this celestial body remains unknown. However, researchers were able to narrow down the search scope. Thus, step by step, we draw closer to our goal. Research on Gemini celestial sources. The mystery of its existence is nearing unraveling. However, this progress has not yet resolved the core issue. What exactly is the nature of this celestial body? Because astronomers can currently only speculate about its true nature, make a vague guess. This fundamental issue remains unresolved. Until 1991, breakthrough progress has only been achieved in related research. 2 independent detection missions all successfully captured radiation signals from the Gemini god. These signals are not continuously stable, but instead exhibit distinct pulsed characteristics. The first major finding among them, the X-ray telescope Rosat, manufactured in Germany. Rosat, the satellite detected X-ray signals from Gemini god first, identify periodic pulse characteristics. Subsequent studies have further confirmed these pulse characteristics, also present in the gamma-ray band. The discovery was made by NASA's Compton Gamma-ray Observatory satellite, high-energy gamma-ray telescope. Complete the observation through cross-validation of multi-wavelength observational methods. Researchers have not only confirmed both X-ray and gamma-ray radiation originate from Jupiter, and for the first time revealed the intrinsic properties of this celestial body. This celestial body rotates with a period of 0.237 seconds. Exhibits typical pulsar characteristics. A pulsar is a rapidly rotating neutron star, capable of emitting periodic, a beam of electromagnetic radiation sweeping across space, like a natural beacon in the cosmos, when observed from the other end of the Milky Way. Most pulsars, manifesting as intermittent radio wave flicker phenomena. Its flashing frequency ranges from several times per minute, up to 700 times per second. Until the early 1990s, such phenomena remain extremely rare, before the lucid enigmatic satellite detectors were put into operation. Scientists, only two high-energy gamma-ray pulsars have been confirmed, the Crab Nebula pulsar and the Vela pulsar. It is worth noting that these two known pulsars and the Needle Gate pulsar. Significant differences exist across multiple key characteristics. First, except for gamma rays, both pulsars simultaneously emit radio waves. Signal. Therefore, observations can be conducted using traditional radio telescopes. This means, if German LAX pulsars will become the first to be discovered, a special pulsar that emits almost no radio waves. Case study. This celestial object is only detectable in the gamma-ray and X-ray wavelengths. Release sufficient energy. Make it. Astronomical observation methods capable of detecting through the corresponding wavelength bands. Detected. Secondly, around the Crab Nebula pulsar and the Vela pulsar. All surround nebula structures formed from supernova remnants. This is when it was born. Interstellar cloud of material left behind by a supernova explosion. The absence of a nebula surrounding the Gemini pulsar. Instead, it appears particularly unusual. The core scientific question raised by this is, why is Gemini, as a strong gamma-ray source, high? It can actually circumvent so effectively observation of existing radio detection equipment. Why traditional radio telescopes failed to detect its signals. The missing nebula structure around this celestial body. What exactly is the explanation? Or perhaps Gemini is essentially, may belong to a previously unrecognized new type of celestial body. Answer to the first question. Partly due to the limitations of our early observations. This was primarily constrained by the technological limitations of the time, and for such stellar remnants, insufficient understanding of radio radiation characteristics. Although pulsars can emit across a broad range of frequencies, transmit radio waves. Its frequency range extends from a minimum of 17 MHz, extending to over 87 GHz, covering nearly half of the radio spectrum. But not all electromagnetic waves across all frequency bands can effectively penetrate cosmic space. Although since the 1970s, the academic community has already confirmed peak radiation of radio pulsars typically appears between 100 and 200 MHz. This band has the brightest frequency range. However, due to the absorption effects of the interstellar medium, the background, the effect of sky temperature, as well as multiple factors such as ionospheric effects, electromagnetic waves in the lower frequency bands when traversing interstellar space will result in significant attenuation, resulting in an extremely weak signal being received. Increased detection difficulty. Given these radio signals, characterized by extremely low strength, the observation strategies of most radio telescopes in the past often narrows the search scope, frequency band limited to 430 to 1600 MHz, rather than specifically targeting these faint signals. Conduct a systematic search. If Gemini celestial bodies follow the typical behavior patterns of similar pulsars, this observation strategy would not have caused any substantive impact. However, that is not the case. Until 1997, scientists have only recently achieved this breakthrough through groundbreaking observations. Reveal its true nature. Pushkino setting. 3 independent observatories under the Astronomical Observatory, utilizing a high sensitivity over the horizon antenna system, successfully captured James Go. Extremely weak pulse signal emitted. As determined, these electromagnetic radiations at frequencies around 100 MHz. It is precisely the radio pulses emitted by this celestial body. This phenomenon explains why previous radio observations, no signal from German God has ever been detected. In reality, this celestial body is not truly hidden or inactive, but rather continuously transmit radio signals toward Earth. The problem lies in, we previously failed to adopt the correct reception method. In the same year, by the late astronomer Yang Lu, research team led by Shi Jie proposed that German exhibits radio silence characteristics. Another potential cause may be related to its magnetic field properties. Theoretical models indicate the pulsed magnetosphere may cause absorption or refraction effects on radio signals. Ultimately, Only a faint pulse signal remains in the approximately 100 MHz frequency band. Detectable. This mechanism, making gemengal, in the vast majority of radio telescopes, commonly used high-frequency observation bands, remain silent. Confirm. Gemengal as the nature of gamma-ray pulsars. Of significant scientific importance. 99% of its radiated energy is concentrated in the gamma-ray wavelength band, making it one of the largest galaxies in the Milky Way. The brightest known gamma-ray source. Research indicates the material present on this celestial body originated approximately 350,000 years ago. A supernova explosion event. The mass of its progenitor star was approximately several times that of the Sun. However, apart from the significant radio silence feature and the absence of nebular structures, this pulsar also exhibits other anomalous characteristics. Italian astrophysics research team, by comparing the European Southern Observatory's 3.6-meter telescope, New Technology Telescope, and from Canada to France, series of observational data from the Hawaii telescope, the object exhibits significant proper motion. Its movement speed is exceptionally high. The average annual angular displacement reaches 0.2 arcseconds. As a supplementary note, an arcsecond is a unit of angular measurement in astronomy, the smallest unit used for precision angle measurement. 1 radian equals 60 arc-minutes. 1 arc-minute equals 60 arcseconds. Particularly suitable for astronomical observation scenarios requiring high-precision angular distance measurement in the field of astronomy, used to describe celestial bodies. Units for observing celestial motion. An Earth-based observation system. If Earth is taken as the reference point, draw a circular track. Simulate the lunar orbit around the Earth. The angular range corresponding to this circular track is 360 degrees. Therefore, at any given moment, the sky area visible to observers is approximately 180 degrees, stretching from the horizon to the zenith, where the zenith position corresponds to an elevation angle of 90 degrees. Through a simple method, visually perceive the angular scale of the sky. Keep your little finger straight and parallel to your arm. When one eye is closed, the sky spanned roughly the width of a pinky fingertip. It is recommended to conduct verification under clear night sky conditions. You will find that the tip of your little finger can usually obscure the moon. On an astronomical scale, Jupiter's annual apparent motion in the sky is 0.2 degrees arcsecond. This value may seem insignificant. For reference, the annual apparent motion of ordinary stars across the sky, only 1/1000 of an arcsecond. However, it is worth noting that, although German is 800 light-years away from Earth, over a period of more than 10,000 years, will continue to move across the celestial sphere by 30 arc-minutes. This phenomenon indicates the stellar remnant is traveling at an astonishing speed of nearly 210 kilometers per second, crossing the Milky Way, and is currently moving toward the boundary region between Gemini and Lynx. Movement is projected based on the current movement rate. Jupiter, it will persist within the Gemini region for approximately 500,000 years. But after that, it may be necessary to redefine its zodiac affiliation. This mysterious pulsar, it also possesses more distinctive properties. Its ultra-high movement speed facilitated scientists. Another significant feature recently discovered, when German traverses space at extremely high speeds, will appear against the celestial sphere background, forming two ghost-like filaments stretching 3 trillion kilometers, X-ray trail. As previously stated, despite the high-speed motion of this pulsar, nearly silent in the radio band, however, in the gamma-ray and X-ray bands, exhibited significant activity characteristics. 1999, the European Space Agency launched the X-ray Multimirror mission satellite, aimed at conducting more in-depth exploration of the X-ray universe. For years later by Patricia, the research team led by Caravaggio discovered these X-ray trajectory exhibiting a comet-like shape. Its morphological characteristics and brightness distribution, partly attributable to jarmaying. When the pulsar moves at high speed in space, shock wave effect generated, and the celestial body's own rotational characteristics. As a typical pulsar, its rotational process plays a crucial role. However, these observational phenomena also reveal the German god. Another important property of its immense mass, although the diameter of this celestial body is only about 20 to 30 kilometers, yet possesses extremely high density, approximately 1.5 solar masses. To facilitate understanding of this concept, if one were to take a teaspoon of neutron star matter, its weight will reach approximately 4 billion tons. When such an ultra-high density and massive celestial body, when traversing low-density interstellar medium at extremely high speeds, will cause significant physical effects. Not only compress the interstellar medium itself to 1/4 of its original volume, while also maintaining the original magnetic field strength in that region, increased to 4 times. At the same time, the continuous rotation process of neutron stars, special environmental conditions were established. In this environment, electrons and their antimatter counterparts, positrons, capable of being accelerated to an extremely high energy state, and thereby gain the capability to emit high energy gamma rays. Although most of these high energy electrons can be accessed through gamma rays emitted by pulsars have been observed. However, some electrons remain bound and spirals along the trajectory of the enhanced magnetic field. Relevant computer simulation images clearly demonstrates the physical processes within the theoretical model. The gamma ray trail follows along the German high-speed edge motion of three-dimensional shock structures. Its dynamic characteristics are similar to those of a ship underway, wake formed on the water surface. It's just that the vessels here possess dimensions far exceeding conventional scale. The tail stream consists of extremely high-energy gamma rays. However, the last unsolved mystery of the German god. It was not until 2005 that the truth was finally revealed. The discovery of its nebular structure. The nebula appears as a structure with a radius of 0.4 arcseconds. The gap's high atmosphere, confirmed as belonging to our defined category of pulsar wind nebulae. This type of nebula forms within the magnetic field of a pulsar jet of plasma wind. Specifically, plasma winds ejected from the poles of pulsars can be accelerated to near the speed of light. These high-energy particles form a cloud around the pulsar and produces intense X-ray radiation, with the confirmation of the existence of the Gemini Nebula. Its nature as a pulsar was ultimately confirmed. The Chandra X-ray Observatory's observations. This led to a more significant discovery. In addition to imaging observations of Gemini, Chandra also studied another black hole named B0355+54 pulsar. Through comparative research, astronomers have revealed potential causes of the absence of radio pulses in Gemini. Surface observations indicate these two pulsars exhibit a high degree of similarity, of comparable quality. The average age is approximately 500,000 years. The rotational speed is 4 to 5 revolutions per second. However, it is worth noting that Gemini is primarily detected in the form of gamma ray pulses, exhibits significant radio emission. In stark contrast to this is another pulsar is invisible in the gamma ray band. It is one of the brightest known radio pulsars. Why are these two pulsars so similar in nature, yet exhibit significant differences in observational characteristics? The answer may be quite straightforward. The rotational axis of each pulsar points in a different direction. This, depending on our perspective from Earth. Astronomers point out, correlated images of Gemini pulsar and pulsar B not only revealed the orientation of their rotational axis, it also explains its radio pulses, gamma ray bursts, the intrinsic causes underlying the presence or absence of a phenomenon, similar to the magnetic field surrounding Earth. Both pulsars possess magnetic poles. Moreover, these magnetic poles are close to their rotational poles. It is precisely these extremes that constitute source of pulsed radio beams. To facilitate understanding of this mechanism, you might want to try using a small foam ball. Conduct simulation experiments. Push a wooden skewer through the center of the foam ball. At this moment, the foam ball symbolizes a pulsar. Radio beams emanate from this sphere. Radio waves emitted by the two poles, by means of wooden pegs extending from both ends. Presented in an intuitive manner, when you spin the sphere around the wooden stick, will form an equator at its center. To demonstrate gamma ray sources on a rotating equator, you can cut a hole in the paper plate, then press it firmly against the surface of the foam ball. At this point, you have constructed a system capable of capturing data from the equator. A disk model emitting gamma rays in all directions. As for James Garr, the edge of the disk is directly facing the Earth observer. This means the gamma rays it produces are propagating toward Earth. However, for pulsar B, due to its entirely different viewing angle relative to Earth, it's as if we were observing a flat surface. Gamma rays moving perpendicular to our line of sight. Therefore, it did not reach Earth. Next, let us take another look at two images captured by the Chandra X-ray Observatory. Related images. On the left is the German guy himself. On the right is pulsar B, also on display. Also, astronomers based on the theory of pulsar wind nebulae. Illustrations of the artist. In the image of the pulsar wall, that slender blue trail, radio jets emanating from its two poles, and the forked structures extending from both ends. Since pulsars must be moving at high speeds in space, these jets exhibit a curved morphology, bending backward and trailing behind its path. Observe the image of the Gemini god now. The two long tails extending from either side of the image are precisely its radio jets, trailing behind while moving in space. However, unlike the aforementioned situation, they do not point almost directly and stay away from Earth observation points, but rather extending outward on both sides. not aligned with the Earth observation direction. Therefore, when astronomers observed the Gamma pulsar, they detected originates from its rotational mechanism, intense gamma-ray radiation. This radiation is primarily concentrated in the equatorial regions of celestial bodies. Its radio jets exhibit a bilaterally symmetric distribution, and is currently invisible under the present observational conditions. In stark contrast to this is, when observing pulsar B, its radio jets point almost exactly toward Earth. Gamma-ray sources in the equatorial region. Then it is within the Earth observation video range. This phenomenon confirms the principle of least explanation, the scientific principle that often comes closest to the truth, ultimately directing research perspectives toward the Earth over decades. The mystery of the unusually bright antimatter, for over a decade. Alpha, mounted on the International Space Station. Magnetic spectrometer particle detection device. Continuously gathering information about antimatter. Key data on dark matter and cosmic ray sources. It should be specifically noted that cosmic rays, in essence, high-speed atomic motion and high-energy particle fragments. Its operating speed approaches the speed of light in a vacuum. These particles may originate from solar activity, supernova explosions or other cosmological processes. The AMS-02 experiment released its first major findings in 2013. The detector has successfully recorded 400,000 positron events. This is not only the first of its kind to date, the maximum scale achievable in a single experiment. Cosmic ray positron samples, and even more so, the total volume of positron data worldwide, achieved a 100-fold increase. For a long time, numerous astrophysicists speculate this antimatter excess phenomenon, possibly a byproduct stimulated by the dark matter annihilation process, thereby providing a breakthrough for unraveling this cosmic mystery. After all, dark matter accounts for approximately 27% of the total mass of the observable universe, but its essence remains an unsolved mystery to this day. Similar to ordinary substances, dark matter possesses mass properties and occupies spatial dimensions, but its special nature manifests as, at least within the scope of current human detection technology, neither absorbs electromagnetic radiation, it does not reflect light, and does not interact with electromagnetic fields. Existing theoretical models generally hold that dark matter may consist of undiscovered new types of particles. Fundamental particle composition. It is precisely based on this scientific expectation. Researchers once hoped to uncover the mystery of antimatter anomalies, to reveal the intrinsic properties of dark matter. Regrettably, the research team ultimately reached a disappointing conclusion. As scientists conduct in-depth analysis of the data, research findings are gradually becoming clearer. The most likely sources of these positrons. It is actually a pulsar. Although astrophysicists have long held this hypothesis, but it wasn't until 2017 that conclusive evidence was obtained. High-altitude water cutting. Observations from the Renkoff Gamma Ray Observatory. This provides crucial corroboration for the hypothesis. Researchers at the observatory, a faint gamma-ray ring has been detected. This orbit encircles the germanium pulsar. Its radiated energy reaches as high as 5 trillion to 40 trillion electrons. Voltage is trillions of times more energetic than visible light. Such high-energy radiation is typically produced by positrons. This discovery, for the first time, the hypothesis that pulsars may be sources of positron radiation, provided direct observational evidence. Research indicates pulsars are characterized by their extremely strong magnetic fields, will naturally form a diffuse structure composed of electrons and their positron counterparts, the halo under the influence of a strong magnetic field. These charged particles accelerated from the surface of a pulsar to near the speed of light. Scientists speculate these accelerated positrons and electrons subsequently collided with the interstellar starlight, enhancing photon energy through Compton scattering, ultimately released in the form of a gamma-ray halo. However, based on the halo size measured by the HAWC team, positrons produced by the JM-bar pulsar most lack the energy required to reach Earth. Therefore, researchers believe observed excess positrons. It must originate from other more specific cosmic sources. Until a few years ago, a startling new discovery has emerged. By astrophysicist Meisha, the research team led by Morrow, unraveled this scientific mystery. The team, using the Large Area Telescope of the Fermi Space Telescope, over the past decade, acquired Gemini, high-pulse gamma-ray observation data. The energy range covered by these data, Hawk, gamma-ray observatories have a lower detection threshold, achieved a critical breakthrough. During the process of precise data processing, Morrow's team systematically, all known sources of gamma-ray interference have been excluded, thereby revealing a spectacular phenomenon never seen before, an energy as high as 10 billion electron volts. Giant ellipse, gamma-ray halo. Its spatial scale spans 20 degrees of celestial area. This astonishing range The constellation Ursa Major, which contains the Big Dipper, is comparable in size. Particularly noteworthy is this gamma-ray radiation. The intensity is more pronounced in the low-energy segment. If observed in the visible light spectrum, this atom, German gamma radiation field, will occupy an area equivalent to 40 full moons, the area of the celestial sphere corresponding to the diameter. This groundbreaking discovery provides significant insights for astrophysical research. Research on the ultra-large-scale characteristics based on the gamma-ray burst. The research team calculated this pulsar system may individually contribute to cosmic rays. The excess positron mass accounts for approximately 20% of the total mass. This quantitative relationship strongly indicates other intranuclear pulsars, highly likely, is the primary source of such high-energy positrons. Although this discovery, the mystery of the nature of dark matter has yet to be fully unraveled. However, its scientific value lies in for the positron excess phenomenon, provided a highly persuasive explanation of astrophysical origins, undoubtedly, is a major area in contemporary high-energy astrophysics. Milestone achievements. 1967. Jocelyn Burnell discovered the first pulsar. At that time, it was widely believed in academic circles that these highly regular signals, possibly originating from an extraterrestrial civilization. Over the past nearly 60 years, humankind has discovered thousands of pulsars to date. With each new discovery emerging, our understanding of this type of neutron star is also being continuously deepened. As humanity in 1991, the third confirmed gamma-ray pulsar, James God's existence is a milestone, thanks to the contributions of NASA's FEMI mission. Currently, number of gamma-ray pulsars discovered by humans has surpassed the 300-unit milestone. However, given Jeremy Gauss's repeated history of surpassing scientific expectations, a chronicle of pushing the boundaries of knowledge, we have reason to believe this unique pulsar still harbors numerous scientific mysteries yet to be revealed.